Hello, my name's Michael Bissell, and this presentation is a 30,000-foot view on a development philosophy. Philosophy doesn't mean code standards, it's not spaces versus tabs, it's not about Java versus C Sharp. Development philosophy in this context is sort of the broad rails that lead us to conclusions for what choices we should make when developing new projects. The very first rule that I always bring up is Steve Krug's book from about 2002 on web design, which is Don't Make Me Think. It's all about making things simple to understand. And it's not just making things simple to understand for the person consuming your application, it's making things simple for you to understand. Affordances are things like labels that make sense so you don't have to stop and think, because every time you stop and think, you slow down, you get confused, you get frustrated, and it makes it more difficult to get these complicated things done. Another way to think about this is designing for total amnesia, meaning you yourself are going to forget what you did. If you have to come back to some code a year later, nobody's going to expect that you actually remember everything that you did in there. So you should make it easy to understand what's going on, not just in the documentation or the comments in your code, but creating contextual error messaging. Two kinds of contextual messaging here. We want nice, friendly messages so that when somebody calls up our support team and says, it's broke, we understand what they mean by it's broke, that we get enough information to lead us to the right direction. And then when we hand it off to the back end team who's looking at log files or console-driven error messaging, that it gives us an idea of where it's broke. Because remember, we have an entire stack of development, and it's not just one thing. I break the stack down into essentially 6 different areas. Everything from a very thin, pretty web application through helper tools that you can use to a layer that abstracts all of the back-end services, and then of course data storage as a very fixed thing way in the back that sits on top of our back-end systems and infrastructure. So let me go through these different areas of the stack because you can kind of think of it as a funnel of flexibility all the way down to rigidity in things you simply can't change. So the very flexible part, of course, is the web application. It's the pretty pictures. It's the most chaotic part of what we're working on because it's going to change on the whims of a marketing team, on the push of a legal question on language. We need this to be extremely flexible. I'm a big fan of using very simple HTML and very complex CSS, meaning the style sheets that change the look of that HTML, because if you do that, you have one place that you change it that cascades through. That's why we call them cascading style sheets. What's interesting is how rarely we actually do that in development because we get into these kind of one-off pieces. And if you're going to have to do a bit of one-off code, the web front end is the right place to do it because this is a specific business practice. This is where we're keeping the business logic for this application. We are applying our back-end technical stack to a business solution. Now keep in mind, as much as I want to push stuff out into the browser is not secure. We don't own the browser, the client does. We're not usually worried about somebody, accidentally doing something we don't want them to do. We want to make sure that somebody who really knows what they're doing does not have the ability to break into that either by, messing with their JavaScript on their end or because they're intercepting the connection. Because, again, this is an all interconnected world and we never know who's listening along the way. Now, when I talk about the quote SDK, the software development kit, it's a kind of amorphous term, but I like the phrase for grids and widgets, things that we know this thing goes here and it looks like this. Big fan of the, using the Bootstrap grid as a standard so that we can drop whatever we want into that. But even if we're not using a standard like that, we should have chunks of code that we reuse over and over again. We have a shared menu for global navigation. We shouldn't be lovingly recrafting that in every application. We should be able to reference it on a CDN and have it show up. We should have an easy code snippet that shows how to do that. If we want to apply single sign-on to a new application, we should have different kinds of code for PHP and Java and C# and whatever else we know we're going to be developing in. It's a matter of then having a central library of tools that is centrally managed. So if we change a menu item, we don't have to chase it down in 50 different places. We simply change it in the CDN and it propagates out because everybody who is consuming these things is following the same basic premise and approach. So now we get to that wall between things that we see outside, things that the consumer can play with and look at and explore. So if our little script kiddie is trying to hack their way in, they're going to run into this wall here, which is the API gateway, the API facade. There's lots of different things we call it, but think of it as a thin layer that applies traffic cop rules. This is where the contract is applied. If I'm going to go get a list of people who belong to a school district, I expect the pagination to work the same. I expect to be able to put the same kind of headers in there to get it back as either a JSON file or as a CSV file coming back as the response. I expect my security credentials to be the same. I shouldn't have to have different keys for different resources. I use one set of keys that may not give me access to other collections until we grant that access. But the developer, that web developer, has one set of keys to get to all data and the heavy lifting processing that happens to make that data do what it does. That heavy lifting processing is now in the API services. We use the word microservices a lot, and I think it's an overused word, but the idea here is that, again, if I have a collection of people, I want to list first name, last name, who they work for, what their title is, that could be one simple collection that is fed from different services. If I want to do an email validation process, which is more of a function than a collection, that may sit on an entirely different stack. It doesn't necessarily have to all be written in Java. It doesn't all have to be written in PHP. It can use different databases behind these services. But this layer is all about creating the functional presentation and handing it back upstream to the gateway so the web application can consume something that appears consistent but gives the flexibility to the developer to build it the best way for what we're trying to do. Now, the data itself, we're getting into something even more rigid. So we have specific rules around how to build APIs in the previous step. Now we have very rigid data structures that should be optimized for flexibility of accessing that data. So those API resources that we're building don't really care specifically about the data structures. They can simply make the queries, but the data can be managed more operationally and not based on the whims of all that chaos way back upstream where we're talking about the web application. The database doesn't need to know about the pretty front end. The database needs to be clean, secure, organized, optimized, managed as a data store, not as part of the application. And then you get to the really rigid part. You get to your operating systems, you get to your CPUs, you get to your physical infrastructure. In a sense, I don't care if we put that on the cloud or if we put it in a big data center that we own where we have a lot of hardware. The reality is it should be a complete abstraction from everything else. Virtual machines are your friends. Being able to use some of those API services that we're talking about are essentially what we think of when we think of cloud solutions with PaaS. All it's doing is running on this hardware. We need to make sure that we're able to patch our kernels, we're able to be able to update all the underlying infrastructure, that we can keep this secure, that we have our firewalls set up. All that bits and bolts stuff should be completely 100% independent of everything that's going up above it in the stack. So that's the entire stack. And of course, there is a little bit of bleed here and there. But the reality is that the more we can kind of separate these things, both philosophically and physically, the more flexible we become, the better the maintenance of our application stack becomes. So let's go a little bit into that physical infrastructure, sort of the, when I say I don't care if it's cloud or if it's a data center. I mean, obviously I do care about certain things in here. The main thing I care about is fiduciary responsibility. The main thing I make sure is that we can pay for it, not just on the front end. We need to think about what it costs to build it, what it costs to maintain it, what it's going to cost to extend it. And part of that is, of course, the concept of pets versus cattle, because pets are something you nurture and you love, and actually pets are very, very expensive compared to cattle, who are just, you breed more as you need more, and you cull them as you need to reduce the herd, and you're not really paying attention to individuals. So the first principle on that, of course, is it should be stateless. Can I kill it? Can I remove it? Can this instance disappear, and do we notice? It should be redundant. It should have a distributed data store so that it's not holding some valuable piece of information on its own bit. That's why those databases need to reside in their own protected layer. The scalability is the breeding bit. Can I clone it? Can I put more in there? Will they know how to talk to each other? They're going to need to have some sort of persistent data so that if something has changed since we made that image, it knows where to check in to get those changes, or it has a distributed cache or something like that, which brings us to that consistency. Can I tell the difference? If I spin a new one up, is it a calf or is it a cow? It should come in as a fully functional, useful member that doesn't need a lot of tweaking or growing on it. So we should be able to create an image that we can just keep making new ones. Like I say, we clone it, we breed it, and then when we don't need them anymore, we cull them, we remove them from the stack. So I know one of the things you're thinking here as a developer, why do I really care? Pets versus cattle, that all sounds very operational. The sysops guys can worry about that sort of thing. But it changes the way that we build our code. Because if you want to build your code in a way that is truly portable, which makes it truly cattle, something that you can actually trade with somebody else, you want to be able to deploy it to your local stack just as easily as you want to be able to put it into our private data centers or put it out into a cloud. And it shouldn't matter if you're putting it into Azure or if you're putting it into Amazon, because it should be service provider independent. This helps us in our development flow because we're using standards, but it also helps us in our disaster recovery. Because if we're stuck using some sort of specific feature in the cloud, in a PaaS service, for example, then how are we going to pick it up and use it? How are we going to test it locally if we're dependent on that? So again, on the disaster recovery, we need portable, functional backups, just like we need portable, functional deployments. And the process of restoring that should be vendor independent. One of the problems that I know we face, because it's so convenient, is to keep an AMI in Amazon. The Amazon image is proprietary to Amazon. I can't take that image and bring it down to my local machine. However, if I did actually create an ISO of that or a deployable code of what I have out there in the cloud, then I could do that. So to sum up, don't make me think. Separate your interests, breed cattle, not pets, and design for independence. Thank you very much. Any questions, any comments? Philosophy is, of course, philosophical and therefore is malleable and very dependent on what we want to do together. So let's keep the conversation going and let me know what you think. Thanks.